evaluate the integral. So we got x cubed over square root of x squared plus 25, a fraction. So we try for u substitution, and u would be the function inside radical sign, this, and when we find its derivative, that's 2x. Okay, 2 can be always managed as x, but we have on the top not only x, we got x cubed, so we cannot manage with u sub. Okay, we have too much on the top. Then if we recall correctly, going through this, square root inside a function is squared plus a number is squared. So when we have u is squared plus a squared, or a squared plus u squared, because it's the same thing when we write a squared, u squared. When we have this one or this form, then we can make a u trig substitution. Okay, trig substitution, and that will get rid of this square root, and we can evaluate this integral. So when we have this form, then we need to replace u by the function by a tangent theta. Okay, so in this case, u is just x and number a is 5, so we let u be a tangent theta. That is, a is 5 tangent theta. Now we want to convert the whole problem in terms of new variable theta. So take derivative dx over d theta, and I'm going to write over here derivative of 5 times tangent theta. 5 is 5, it's times. Now we take derivative of tangent, that is secant square theta. With this integral becomes x cube 5 tangent theta cube. 5 cube means 5 times 5 times 5, 125, and tangent theta cube means tangent 3 copies, all over square root of x squared plus 25. Let's work out here so that we don't have to copy everything. X squared plus 25 is in fact, with our substitution, x squared means 5 tangent theta quantity squared. So 5 is squared 25 tangent square theta plus 25. Inside radical sign we can factor 25 out. That leaves tangent square theta plus 1 times. Now we can take square root of 25, which is 5. And inside we got tangent square theta plus 1. That is secant square theta. It's a trig identity. We know that 1 plus tangent square theta is secant square theta. Now we can cancel. So 5 secant theta. Okay. Now this radical sign is gone. With this nice substitution, we get just 5 secant theta. Okay, that's the whole purpose of making this substitution, so that the radical sign is gone. Times we have dx, and that we found 5 secant square theta d theta. Now from top and bottom 5, cancel this. Secant 1 copy, we can cancel 1 copy there. And this 125 number we can always pull outside. That leaves tangent cube theta secant theta. 1 copy cancel with bottom d theta. Okay, now we got a product of tangent and secant. Okay, it's times, you can write or you don't have to. And now we need to recall the rule. When we have tangent and secant has odd power. Okay, secant 1. When we have secant with odd power, then our u should be secant theta. You know why? Because u equals tangent theta, not gonna work. Because derivative of tangent is secant square, and we don't have enough secant square, just 1 here. Even if we have, even if we had 3, then that would be bad, because we need square or fourth, etc. So tangent is not the candidate. When we have secant with odd power, then our u will be just secant theta. Okay, then we need to convert in certain way. Let's see here. So we said our u will be secant theta, and derivative of secant is secant tangent. So we save a copy of secant tangent, and here is d theta. This secant is gone. One copy of tangent is used, so we have now, I'm writing pretty much one tangent and tangent is square. You can think in this way. This one tangent is here, and remaining tangent square is secant square minus 1. I mean, this is, we know this formula. 1 plus tangent square is secant square. So if we subtract 1 from both sides, tangent square is secant square minus 1. So we need to convert remaining tangent into secant square, and this is how we can go through. Okay. Now we do a u substitution. U is secant, okay, because we had u odd. Then secant odd, then du is what? Because u is secant theta, then du is derivative of secant is secant tangent d theta. So this whole thing is in fact collectively du. So we can just say, oh, this is simply du. I'm kind of using shortcut here, and this is this is u square minus 1. So the whole problem now becomes u square minus 1. Integral of u square minus 1. Okay, it simplifies. So 125. So this is u square minus 1 du, or you can solve for d theta and replace d theta by du over secant theta tangent theta and cancel. At the end of the day, you will have same thing. So 125. Now we can integrate antiderivative of u square with respect to u, just power rule, u 3 over 3 minus antiderivative of 1 is just u plus c. Now we need to back substitute twice because u is secant theta. So I can distribute 125, not needed. 125 u cube means, okay, let me write 1 over 3 1/3, just the number first. 1/3 u cubed. U cube means secant theta cube or secant cube theta minus u is secant theta plus c. But the question was not theta, so we need to use this initial substitution to get back to the original variable, which is x. So x equals 5 tangent theta. So I'm going to write that. So this is 3. Okay, this is bothering me. So 3. So original assumption was x equals 5 secant theta. No, sorry, 5 tangent theta. My bad. X was 5 tangent theta. Based on this, we can make a right triangle. Divide by 5. So x over 5 equals tangent theta. That means the right triangle is tangent is opposite over adjacent. Okay, we know that tangent theta x over 5 means tangent is opposite over adjacent. So opposite over adjacent, x over 5. Now we can find this c. A square plus b square equals c square. A square plus b square equals c square. This is c, by the way, hypotenuse. A means 5 square 25 plus b means x square equals c is unknown. Now take square root of both sides. So we get 25 plus x square, or x square plus 25, same thing, equals c. and somehow this this unknown side always comes back to one of the radicals in the question, x squared plus 25. 25 plus x squared, or because plus means it's same thing. So this side is x squared plus 25. Now using this we can finish this problem. So 125 times quantity 1/3 secant theta cube, by the way, this is cube, secant theta cube. So how do we find secant theta from here? We know that cosine theta is adjacent over hypotenuse. Adjacent over hypotenuse. 5 over hypotenuse is 25 plus x squared, or x squared plus 25, same thing. So cosine theta is 5 over square root of x squared plus 25. Okay, you cannot simplify. I mean, this is not 5 plus x. Then, but we have secant theta here. Secant means reciprocal of this. So this is then reciprocal, just x squared plus 25 all over 5. And 5 cube is 125, but no need to simplify. That's secant theta cube minus, secant theta, that's here, x squared plus 25 over 5. That's it, plus c. So this is the final answer. Maybe let me circle